we started section 111 on Monday, we looked at the domain and range of a basic number line. Domain and range of a basic number line. After that, so on Wednesday, we went off of a number line and used the whole graph. How to find domain and range from a set of points. How to find domain and range if we knew where it stopped and where it ended. And we did 4 examples of how to find domain and range if any part of the graph goes on forever. So, notice that there were a couple times in which the domain was all real numbers. As I mentioned, there is a time in which both the domain and the range are all real numbers. So here's an example of when that would occur, just so that you know it does happen. So this is an example of when it would happen. So what I wrote in black is the X and Y coordinate plane. And my red line, and my red curve, is the graph. So you have 2 arrows. One of your arrows is pointing up and to the right. One of your arrows is pointing down and to the left. So if you look at domain and range, domain means you're going from left to right. So based off of this graph, you're going to the left forever, you're going to the right forever. Forever and forever. So remember, if you have forever twice, that's all real numbers. So that's all real numbers. Let's look at the range. Good. What did it say in the directions? Oh, okay. Then that means all you have to do is give domain and range. You do not have to draw the graph. Alright, so for range, that's lowest to highest. So you have an arrow pointing down, so that means it's going to be going down forever. You have an arrow going up, that means it's going to be going up forever. So forever and forever means all real numbers. So there is a situation in which both the domain and the range are all real numbers. So it can happen. Does it happen a lot? About 50-50. But it does happen. Any questions before we move on? So that was example 13. All right. So we plotted points, we've evaluated the function, we found domain and range. There are more things that you can do with a graph than just those things. There's more things you can do with a graph. So, there are other key parts of a graph that you need to know how to spot. So we're going to go through each of these definitions. So these are definitions. You have to know what it means in order to be able to identify it. So I'm going to tell you what the name of it is, what it means, and for each one there's a picture that goes with it. So of course, if anything doesn't click, you should be asking about it. Type in the chat or coming off of mute and using your voice and saying it, because closed mouths don't get fed. So let's start with the first two. First two are pretty straightforward. A function with a graph that is a single straight line is called linear. If you just have a single straight line, one straight line, then that's linear. So if the graph is not a straight line, that's non-linear. So the first two are pretty simple. Linear line, non-linear, not a line. Next two. Where the graph touches the x-axis. So notice that there is a point that touches the x-axis. Here's your x-axis. There's a point on it. There's a point that touches it. That is called the x-intercept. Similarly, if it touches the y-axis, that is called the y-intercept. So you have a y-intercept and an x-intercept. Any questions on the first four definitions? Any questions on the first four? All right, cool. You got 45 seconds to do that. So again, if you need to write them down, take some time now to do that. Just know if we move on and we haven't written them down yet, that's okay. The notes go to Google Classroom, so you'll still have access to them. So we'll be moving on to the next part shortly. I'll move it up halfway. Then the rest of it take care of itself. Alright, next one. Where the graph lies above the x-axis. So above the x-axis is everywhere that you see that I'm highlighting in yellow. So if it is above the x-axis, we call that part of the graph positive. call that part of the graph positive. If it's below the x-axis, so if it falls below the x-axis, this is the part that I'm shading in green. If it's below the x-axis, it's negative. I didn't want to be raised with this one. So that's positive, it's above the x-axis, negative, it's below the x-axis. When the graph goes up from left to right. So, when the graph goes up from left to right. So if you look at this graph, look at the little curve, there's a part that I just traced in blue. If you go from left to right, that graph is going up. We call that increasing. We call that increasing. When the graph goes down from left to right. So there are two parts that I'm putting in red. Two parts that I'm putting in red. The graph is going down if you look at it from left to right. So key here, you must look from left to right. Just like the order of operations. You must look from left to right. That we call decrease. That we call decrease. So, let's take another moment here. Let those people who need to finish copying, finish copying. If you have a question about any of these four definitions, please ask them now. While we're waiting for some other people to finish writing. If they have a question on definitions, please ask them now. Finish copying. Maybe another few more seconds, and then we'll do the last three definitions. Alright, last three. Probably keep increasing it there in case you're copying those. So, has the greatest y coordinate. So greatest y coordinate means biggest y value. So, wherever the biggest y value is, which would be where this point is, that is called the maximum. The least y coordinate, which is the smallest y value, down there, that is called minimum. And then the last definition, describe the values of a function at the positive and negative extremes of its domain. So basically, when it asks you what's happening, what are the two arrows doing? So you know how we've been doing this arrow's pointing up, so that means it's going up and to the left. This arrow's pointing down, so it's going down and to the right. That actually has a special name for it. That's called end behavior. It's called end behavior. Now that one we won't really worry too much about because you get into that a lot in Algebra 2 trading, which is your math class your junior year. So we won't be worrying too much about it in Algebra 1. Not to say it won't come up, but we don't get too much into it. So, I'll give you a moment to copy those if you need to copy it, and we're actually going to roll this into your break. So, take 2 minutes to either. So now that we have gone through all of the definitions, now we're going to put them to practice. Now we're going to put them in action. So to put them in action is very, very simple. We're given a graph, and we're going to find the information about the graph. Find the information about the graph. So we have to ask, is it linear or nonlinear? Domain, range, x-intercept, y-intercept, increasing, decreasing, constant, maximum, and minimum. So these are all the things that we're being asked to identify. We're being asked to identify. Now, on a quiz or a test, that's a 10-point problem because there's 10 things that they're asking you. So we're going to go through the process of looking at each part. Some things are easy. Some things take a little bit of thinking. But we can get it done nonetheless. So, first part. Is it linear or nonlinear? So you look at this graph and look at what they gave you. Is that linear or nonlinear? Is that a single straight line? That's linear. That's linear. So remember, if you're struggling, you can't sit there and be quiet. Sit there and being quiet means you know what you're doing. I'll find out over the weekend and definitely next week if you know what you're doing. So, next thing, domain. So remember, domain is left to right. Left to right. Farthest to the left, farthest to the right. So, how far to the left does the graph go? Type it or you can say it. So how far to the left does this graph go? -2. How far to the right does this graph go? 3. So -2 on the left. Since there was a closed circle, you put less than or equal to. The 3 had an open circle on it, or it was open before I drew that line. It has an open circle. So you put a less than sign. X goes in the middle. So, those rules don't change. Just because we didn't go through it in the table, those rules don't change. We're now building on it. Math always goes on itself. Next part is the range. range is lowest to highest. There's my lowest, there's my highest. What's the lowest value? Which is not put, don't we gotta put the -3? Negative for 3. So the -3 right here is the y value. Y value goes with the range. The +3 over here is on the x-axis. So that's a +3 for the x. This is a -3 for the y. But that is the lowest value. So what's the biggest y value? What's our biggest y value? And that's 1. Good job, Noah and Sanaa. Let's see if I'm not understanding domain that well. So domain, you have to tell how far on the left and how far on the right the graph goes, Tyler. So this might be something that I need you to come in during this learning time after school, after class ends, and we go through this some more, because I know you've said this a couple times now. So I need you to start investing that time after school so we can work more one-on-one as well. I want you to get it, but you got to put in some effort too outside of class as well. So lowest number is -3, highest number is 1. -3 has the closed circle, less than or equal to. 1 has the open circle, just less than. And the letter you use is y. So, any questions on the first 3 parts? Any questions on the first 3 parts? Uh-huh. For range, you look from lowest to highest. So lowest point, highest point, and you go to the y-axis. Uh-huh. So that's based on the dot. So the symbol you put is based on the dot that was attached to that number. Well, the range, for the range, the process you do is you got to go to the y-axis and figure out where's that point against the y-axis. So this point that's in black, you have to figure out what does it correspond to on the y-axis. So you need to trace the point back to the y-axis. Same thing with the other point. You have to trace it back to the y-axis. That's how you get range. To get domain, you take the point and you trace it back to the x-axis. So range has to go back to y, domain has to go back to x. Domain always goes to x-axis, range always goes to y-axis. So hopefully that clarifies what you have to do. So, next 2 parts. X-intercept and y-intercept. So the x-intercept. X-intercept means you go to the x-axis, which I just colored in pink, and you identify where does the graph, where does the graph touch the x-axis? Where does the graph touch the x-axis? And then you tell what that number is, tell what that value is. So that point represents where the line touched the x-axis. And it looks like it's touching it close to the number 3. So that's your x-intercept. X-intercept means it's touching the x-axis. And you're identifying where it is. Y-intercept means it's touching the y-axis. So I'm tracing the y-intercept, y-axis in green. The graph is touching it right there. So you count to see what that number is. -1, -2. Any questions on those two? Not seeing or hearing them? Let's do the next part. Clean this off so that we're just looking at the line. So, increasing, decreasing, and constant, we're looking at the x-axis only. X values only. So we go back to where the graph starts. So the graph starts at -2. X equals -2. Now increasing means the graph is going up. Decreasing means the graph is going down. Constant means the graph is flat. So if I start at -2 and trace this line, am I going up or down? What am I doing? So, I'm going up. Is there ever a point where I go down? No. Start from the left and go from the right. Go to the right. No. So you never go right to left. You never go right to left. You only go left to right. You always go left to right. So always go left to right. Just like the order of operations. So when they ask you where is it increasing, you would put it from x equals -2 to x equals 3. It was going up from here to there. And that's it. Problem over. They ask you where is it decreasing, the graph never went down. If I'm going from left to right, it never goes down. So that's nothing. Was it constant? No, because the graph was never flat. So, any questions on those three? So constant means it's going flat. Constant means the graph is completely flat. So it's literally a flat line, similar to what I just drew at the top. So that's constant. It's literally just a flat line. Alright. And the last one is maximum or minimum. So maximum and minimum is y values only. Y values only. So increasing, decreasing constant is x values. Maximum and minimum are y values. So we want to know what is the biggest y value and what is the smallest y value that this graph has. What is the biggest y value and what is the smallest y value? So what's the smallest y value? -3. So that means -3 is the minimum. What's the biggest y value? 1. So that means 1 is the maximum. That's it. Problem's over. We've done all 10 parts. We've done all 10 parts. So, any questions on example number 1? Alright, example 2. We're doing the same 10 things. We're going to do the same exact 10 things. So, first off, is this graph linear or nonlinear? That's nonlinear. Too many curves. Too many curves, so it's nonlinear. So domain is left, right. What's the farthest to the left? How far to the left does the graph go? Uh-huh. And how far to the right does it go? Just 4. So -5, 4. There's an x in the middle. If you look at -5, what kind of circle is that? Closed. So that means it's less than or equal to. On the 4, what kind of circle is that? That's closed too. So you can use less than or equal to again. So there's our domain. Range. That's a different color. Lowest value, highest value. Lowest value, highest value. So what's the lowest value on the y-axis? That the graph touches. -5. That's down here. So if you saw this and said -3, don't forget about the part that goes a little bit lower. What's the highest part of this graph? So if you're looking here, Don't forget that there's a part of the graph right there that's positive 5. You get negative 5 less than or equal to y, less than or equal to positive 5. So when you look at a graph, you got to look at everything. When you look at a graph, you got to look at everything. When you look at a graph, you got to look at everything. Any questions before we continue? All right, x-intercept. So x-intercept, I'm highlighting the x-axis. So the x-axis is highlighted. So the graph, the curve, touches the x-axis there, there, there. So it touches it 3 times. We need all 3 numbers. We need all 3 times they're in touch. So what's our guesses? Yeah. What are all 3 of them? 3 is definite. The other 2 you might have to give an estimate. So negative 1.5, since it's on the negative side. Negative 4.5. No, I see, I can go with that. So again, if it falls in between, especially since you're looking at it through a computer, if you're off by 1, let's see, so if you said negative 4.5 is correct. If you had said negative 4, how would you? You'd probably, no, negative 5, it doesn't look like it's really touching negative 5. But if you had said negative 4, I would have given you credit. Again, give you a little bit of leeway since you're looking at it through a computer. Y-intercept. So, for the y-intercept, I'm tracing in blue. So, we're looking at it right there, and I would say 4 is right on point. 4 is right on point. All right. Increasing, decreasing, and constant. So increasing, decreasing, and constant. So you look at x values only. And look from left to right. Alright. So, follow along with me. We're about to trace the graph. Start on the left. Am I going up or down? We're going down. So we're going down all the way until we get to negative 3. So this part of the graph is going down. Let's keep going. I stop at negative 3. The ball is bouncing. Are we going up or down? So now that's increasing. Yep, we're going to do it part by part, but we're figuring out what it's doing first. Then, once we get up there, what is it doing? It's decreasing again. It's going down. So notice that there's two parts where it goes down. There's one part that it goes up. So now, let's write our answers. So again, look at x values only. So the first part is x negative 5 to x equals negative 3. So the first part is from negative 5 to negative 3. And then the other part is from 1 to 4. Again, you're only looking at the x values. You're not looking at y values. So right now, just pretend that the y-axis doesn't exist and that it's not there. Increasing. It started increasing here, stopped increasing there. So it started at negative 3 and it stopped at 1. From negative 3 to 1. Now, I'm a color code type person. That's why I put everything in different colors. So from positive 5 to 4. Because you only look at the x values. So it's a good question. It's a great question. But increasing, decreasing, and constant only looks at the x values. So speaking of constant, is there any point where this graph was flat? No. So this is none. Any questions before we do the last part? Alright, time to wrap this part up. Maximum and minimum, you look at the y values only. You look at the y values only. So, what is the biggest y value that this graph touches? That would be 5. Yep. This part of the graph touches y equals 5. So, there doesn't have to be a point there in order for it to touch it. As long as it touches it, it's valid. Now we need the lowest y value. So what is the lowest y value that it touches? That would be negative 5. So the lowest y value is sitting right there. That's it. Problem's over. Any questions on problem 2? before we prepare to close up shop? So, again, one thing to keep in mind, it's not easy. It's definitely not easy. But the one thing that you have to do is you have to know what the definitions are. So you have to know what it means for something to be increasing, know what it means for something to be a y-intercept, know how to find a domain. Knowing it is half the battle. Finding it out, figuring it out, becomes easier once you know what you're trying to get. So those of you who are struggling, it's okay to struggle. But now, the work has to be put in to figure out that struggle. So know maximum means what is the biggest y value that the graph reaches. So basically, if you were throwing a ball in the air, the maximum would be the highest point that the ball touches. On a graph, maximum is the highest point that the graph reaches. Minimum is the lowest point that the graph reaches. So if it's a ball, the lowest point that the ball is going to reach is the ground. Whenever it touches the ground, that's the lowest point. No problem. Any other questions before we close up shop? All right, not seeing or hearing, so let me